So let's see how we can manipulate power by looking at subjects, looking at the people and participants in an experiment. First of all, the simple thing we can do is increase, as we've said before, the number of subjects. So we can just have more subjects. This is particularly important if the big difference or the noise effect is the difference between people. So if people are quite different in terms of the kinds of errors they have when they use your software, or the delays they have, or anything else to do with the way that one person differs from another. Another thing we might do is keep the same number of people, but just do more trials. So this works particularly well with things like physiological experiments, so perhaps a Fitts law experiment, where in some ways each person behaves relatively similarly, but each time they do the same thing, they might do it differently. So with the Fitts law experiment, you get them to click again and again and again at a target, moving. In fact, the original Fitts experiment was done with relatively few people, but with huge numbers of trials for each person. You notice both these effects are about increasing number. At the top right of the screen of the slide, you can see the number effect noise triangle highlighted, so that on each slide will do that to tell you which thing is being manipulated. However, remember what we've said from the previous part of this part. You might need to have lots and lots of trials and subjects in order to make a difference to the power. In general, if you want to reduce the noise by a factor of 10, you need to increase the number of participants by a factor of 100. So this is an easy way to do things. It's an effective way in terms of it doesn't change the nature of the work you're doing. But it can be quite expensive in terms of the number of people you need, sometimes impractically so. The second thing, which is a very common manipulation to see, is to look at within subject or within group comparisons. What you try to do is instead of putting half the people to use system A and half the people to use system B, you get everybody to use both systems. This is particularly good if the variation between individuals is very large. This happens again particularly strongly in collaborative exercises. If you have groups of people, not only do you have individual differences within the group, but the social dynamics of each group vary. So if you have one group using one system and one group using another system, it's very hard to tell whether the effect is due to the fact the groups behave differently or the systems are different. So what you do within subject or within group experiment, you give each person, as I said, both things to try. So at the bottom you can see that graph. You can imagine this is obviously much more pretty and than you really get in practice. But you can imagine this is the extreme case where we've got a number of subjects, and you can see that in condition A, subject 1 does a bit better in condition A than condition B. Subject 2 simply does a bit better in condition A, condition B. But each subject varies hugely between them. So if you were to have forgotten which subject, or just had 20 subjects and given half system A and system B, you can sort of imagine scrunching that graph together, you'd see very little change. But by looking at the differences, you actually have a very consistent difference. Now this again comes with a cost. If you're going to give each person both systems, then you can have effects that whichever one comes first might get the better or the worse result. Sometimes people learn better, so you do system A followed by system B. They do better at system B basically because they've learned with system A. Or sometimes it can work the other way around. You've got two systems, they got used to one system, you give them a different one, and then they do worse at it because it's second. You get round that by doing things like changing the order. So some subjects you give A then B, some you give B then A. But then the interferences between them may not be symmetric. So there's not a perfect answer, but this often works very powerfully. I said particularly if you have very large inter-subject differences. Another thing you can do is to accept that subjects are different, but to try and match them as much as possible. This is particularly true if you feel that the differences are due to something that you can measure. For example, in educational experiments, you'll often take a class full of children, you'll order them by some sort of pre-test or perhaps just how good they are at some subject or some kind of problem based on previous teaching or previous examinations or experiments. And then sort of put alternate ones into each group so that they have the same proportion of weaker students and stronger students. And then you give one group of students, you teach in one way, one in another way, and compare the outputs. So in some sense, what you're trying to do is match pairs of people and say these are similar enough that we can sort of treat them as clones. You notice with the paired experiment, if you could clone people, you wouldn't have an order effect. You could clone the person, give one clone system A and one clone system B, and in a way that's trying to do this. The problem with this is it's obviously not always possible to know all the effects that are important. You can balance the effects you think of. You might balance on gender, on skill, on age, but of course there may be other things that you've not thought of. And also just people vary for so many different things in life that are nothing to do with anything you'd ever consider measuring. So it can help, but it doesn't often get rid of all the problems. But again, all you're trying to do is trying to reduce that noise. And if you can reduce that noise enough, then you suddenly, small effects become visible. A sort of similar thing you can do, which is more restrictive on the experiment, is to try and have a very targeted user group. So instead of having, every age, every kind of person, you say we're going to look at one very, very specific kind of person. It might be very highly educated people from a particular social situation. In fact, it's usually psychology students in universities or computer science students in universities. But even within that, you might go very, very narrow. Perhaps choose a group that you might believe have a particular problem that they will have with one system or other. So, a classic might you go for novice users and be particularly interested in their results, or maybe even older users because you'll know there may be short-term memory issues. And the idea is this might show up differences that might otherwise be invisible. So if you had lots and lots of types of people, they vary so much you can't tell. But by going this very tuned group and tuned to a group that you think might make a difference, then you might see that difference. Of course, the problem with this is you've gone for this very narrow group. How do you know that what you see for that group will be true for other people? And the answer is you might be able to reason that by making sense from perhaps discussions you've had with the people, fine observations of the kinds of things that go wrong and go right with them. Or you might not know, and what you might use this as a way of saying, yes, there's an effect, we've seen an effect, now it's worthwhile putting in the extra effort to generalise, either by looking at other very targeted groups or a very large population. But you know there's something to look for, and therefore it's worthwhile putting in that effort.